7.6 rotations and the rotation symmetry. Let's look at 3 photographs on the screen first and think about 2 questions. The first one is, how are the windmills in these 3 photographs the same? How are they different? So we find that all the windmills in these 3 photographs share one common feature. This common feature is that those 3 windmills have the rotational symmetry. What is a rotational symmetry? Let's look at the definition here. A shape has a rotational symmetry when it coincides with itself after rotation of less than 360 degrees about its center. The number of times the shape coincides with itself during one rotation of 360 degrees is the order of rotation. So here we have 2 concepts to understand. The first one is rotational symmetry. The other one is order of rotation. So let's use an example to help us understand these 2 concepts better. Here I have a shape which looks like a cross symbol. This one can coincide with itself 4 times in one complete rotation. So we can say this one is rotational symmetry. And you also can see this one has a rotational symmetry of 4. This 4 is the order of rotation as well. For each match, the shape rotated 90 degrees. We see the angle of rotation symmetry is 90 degrees. This 90 can be obtained from 360 degrees, which is the measure of one rotation, divided by 4. The 4 here is the order of rotation. So let's look at how I can make 4 times to coincide this shape with its original shape in one rotation. The rotation center is in the middle of the cross symbol. Let's rotate 90 degrees clockwise first. With 190 degrees, I can find the shape coincides with itself. Let's look at if I rotate 180 degrees clockwise, can I still get to the shape overlapping with its original shape? So this is 90 degrees. With another 90, I rotate 180 degrees clockwise in total. I find this shape still coincides with its original shape. So let's look at the third rotation, where I want to rotate 270 degrees counterclockwise. One time for 90, the second time for 90, the third time for 90. So after I rotate 90 degrees 3 times, this cross symbol still can overlap with its original shape. So let's look at the last rotation. This time I want to rotate 360 degrees. 190, 180, then 270 degrees, then 360 degrees. After I rotate 360 degrees clockwise, this shape can coincide with itself 4 times in one rotation. So therefore, we say the order of rotation in this example is 4. Then I can use 360 degrees, which is the measurement for one rotation divided by the order of rotation. This is the angle of rotational symmetry, which means how many degrees do I need to rotate in order to coincide the rotation image with itself. And we need to pay attention to this one. A shape that requires a rotation of 360 degrees to return to its original position does not have rotational symmetry. A shape cannot have rotational symmetry of order 1. So this one means if you need one complete turn to coincide the rotational image with itself, this one does not have the rotational symmetry because we never have the order of rotation 1 for any rotation. So let's complete the chart in example 1. Find the order of rotation or angle of rotation symmetry. And then remember, based on this formula, we know that 360 degrees divided by the order of rotation equals the angle of rotation symmetry. If I multiply both sides by the order of rotation, I will have order of rotation times the angle of rotation symmetry equals 1 full turn, which is 360 degrees. So right now, in the first question, I have order of rotation 2. Let's find the angle of rotation symmetry. So the angle of rotation symmetry equals 360 degrees divided by the order of rotation. So this one is 180 degrees. That means this shape will need 180 degrees in order to coincide with itself. If I have the angle of rotation symmetry, which is 60 degrees, I want to find the order of rotation. I will use the order of rotation times 60 degrees equals 360. If I want to find the order of rotation, I use 360 degrees divided by 60 degrees. So this one has the order of rotation 6. So this one means the shape can have 6 times coincide with itself in one rotation. So the order of rotation is 10. What is the angle of rotation symmetry? I will use 360 degrees divided by 10. So it's 36 degrees. This one means for every 36 degrees rotation, you will coincide the new rotation image with itself. The angle of rotation symmetry, which is 120 degrees here. So the order of rotation will be 360 degrees divided by 120 degrees. So it's 3. So in one complete rotation, the shape can have 3 times coincide with itself. Let's look at an example to identify shapes with rotational symmetry. Determine if the hexagon below has a rotational symmetry. If this one has the rotational symmetry, you need to state the order of rotation and the angle of rotational symmetry. So if I want to decide if this hexagon has the rotational symmetry, I will try to rotate this one around the rotation center. The rotation center is here. So let's look at the methods. We join one vertex to the center point. So I will join this vertex to the center point. Then trace the hexagon. Rotate the tracing about the red dot and record of rotation. So what I will do is, right now I rotate this hexagon about its rotation center. I will see after I rotate this much, this hexagon can coincide with itself. So after I rotate 120 degrees, this hexagon can coincide with itself. So let's continue to rotate another 120 degrees based on this one. So another 120. So I will find after I rotate another 120, this hexagon can overlap with itself. So I rotate 240 degrees, the hexagon still can overlap with itself. So let's rotate one more 120 degrees. So this is the last 120 degrees, which makes 360 degrees as a complete rotation. The shape coincides with itself again. So I will see in one rotation, this shape has 3 times coincide with itself. So the order of rotation is 3. The angle of rotation symmetry is 360 degrees divided by the order of rotation, which is 3 here. So the angle of rotation symmetry is 120. The 120 means if you rotate 120 degrees at a time, the shape can coincide with itself. Let's determine which hexagons below have rotational symmetry. You can use the tracing paper. If this one has the rotational symmetry, please state the order of rotation and the angle of rotational symmetry. So let's look at the first one, which is a convex hexagon. Let's rotate this one around the rotation center. With this many degrees, it's not coincide with itself. was 90 degrees. The new one does not coincide with its original one. So let's keep rotating. This is 180 degrees. I find with 180 degrees, this hexagon can coincide with itself. So let's rotate another 90, 270. It does not coincide with itself. 360 degrees. So this one coincides with itself 2 times in one rotation. This one means the order of rotation is 2. And the angle of rotational symmetry is 360 degrees divided by 2, which is 180 degrees. That means every time you need to rotate 180 degrees in order to have this hexagon coincide with itself. So right now, let's look at this concave hexagon. I will rotate this one with 90 degrees. It does not coincide with itself. Another 90, 180 in total. This red one still does not coincide with itself. 270 does not coincide with itself. 360, it coincides with itself. So this one can coincide with itself after one rotation. So we find that the order of rotation for this shape is none. The reason why this shape does not have the order of rotation is because a shape cannot have the order of rotation if it requires 360 degrees to coincide with itself. Let's look at an example 4, drawing rotational images. So we can use the square grid paper for rotations of 90 degrees, or any multiple of 90 degrees, such as 180 degrees and 270 degrees in the rotations. We can use the isometric dot paper for rotations of 60 degrees or any multiples of 60 degrees, such as 120 degrees and 180 degrees. So let's look at the first one. Rotate the pentagon ABCDE 90 degrees clockwise about vertex E. Draw the image on the grid. Draw and label the rotation image. If you have a little bit trouble in rotating this pentagon ABCDE about the point E, you can use the tracing paper to help you. So here, I want to rotate this one around E. So this one should rotate around E. So E should be a fixed point. So rotate 90 degrees clockwise. So that's 90 degrees clockwise. So this one, the red one, will be for the rotation image. Point E is the rotation center. So this E is not only on the original shape, but also on the rotation image. You will see D goes to this one, D prime. C will go to this one. And B will go to this one. This one is the A prime. Let's rotate the trapezoid FGHJ 120 degrees counterclockwise about the vertex F. Draw the image on the grid. Draw and label the rotation image. You will find those dots are different from those dots. Those dots are called the squared grid paper because in the first one, I only need to rotate 90 degrees clockwise. But in the second one, I need to rotate 120 degrees. 120 is a multiple of 60. So this reason you will see all those dots, they can form the equilateral triangle. So those kind of dots are called isometric dots. So I want to rotate this trapezoid about the rotation center F for 120 degrees counterclockwise. Counterclockwise, that means you rotate this way. You rotate this way. So rotate around this point this way. Let's continue to rotate. 120 degrees will be, so after I rotate 120 degrees counterclockwise, for this FJ, I rotate 120 degrees. This is 60, another 60. This one is 120 degrees. So Fj becomes this one. So this is J prime. The point next to J prime is H prime, which is corresponding to H. So Fg, this is 60 degrees, 60 degrees. So the blue trace shows me I rotate 120 degrees counterclockwise to get G prime here. So that's how I can get to the rotation image after I rotate 120 degrees counterclockwise. Let's look at example 5. Identifying symmetry after rotations. Let's label the x and the y-axis on the new grid. Draw the rectangle ABCD with the same coordinates on the new grid. Draw and label each rotation image. So we need to rotate 90 degrees clockwise about vertex A. So vertex A is here. I want to rotate this one. So I can also split the whole shape into line segments. So for a rectangle, I will have 4 line segments. This time, I only need to rotate each line segments. So AD is rotated by 90 degrees clockwise. So this one will be D prime. For AB, this side, I rotate 90 degrees clockwise. So this one will be B prime. So the other two sides, BC and CD, if I rotate these two line segments about this A, so one side will be here, which is C prime. The other side will be here. So I will have A, B prime, C prime, D prime. So this is the rotation image for 90 degrees clockwise about the vertex A. So right now I want to rotate this original shape 180 degrees clockwise about the vertex A. So if I want to rotate this one, I want to rotate line segment AB first. Line segment AB was 180 degrees clockwise. This is 90 degrees clockwise, 180 degrees clockwise. So I will mark this one as B double prime. So AB double prime corresponds AB. Then I will rotate this AD 180 degrees clockwise. So clockwise 90 degrees, 180 degrees. So I will mark this point as D double prime. Then the other two sides, you almost can imagine already. So I will make the other two sides for this rectangle. Here is C double prime. This green one was A, B double prime, C double prime, D double prime. It's the rotation image of the original one was 180 degrees clockwise about the vertex A. Let's look at the last one. This time I want to rotate 270 degrees clockwise about the vertex A. So I will still use the line segments to help myself for the rotation image. So I will rotate this AB about this point A, 270 degrees clockwise, 90 clockwise, 180 clockwise, 270 clockwise. So I will use the purple color to highlight this side. And this B, I will call this B triple prime. So A, B triple prime corresponds AB in the original one. Then I will rotate AD 270 degrees clockwise about the vertex A. 90 clockwise, 180 clockwise, 270 clockwise. So this point should correspond to point D in the original one. I will mark this one as D triple prime. Then highlight this line with the purple color. Then I can make a rectangle here. So this one should be C triple prime. So the purple one was A, B triple prime, C triple prime, D triple prime. It's the rotational image of the original one was 270 degrees clockwise about the vertex. So right now, let's look at the big shape formed by the original one A, B, C, D, and the first rotational image, the green rotational image, and the purple rotation image. So the resulting shape is BC, D, B prime, C prime, D prime, B double prime, C double prime, D double prime, B triple prime, C triple prime, D triple prime. So this big shape, let's highlight with yellow. Let's look at this big yellow one. If this yellow one has a rotational symmetry, if you rotate this big one, you will see the big one has a rotational symmetry of order 4, about point A. So point A is in the central part. So point A is the rotation center for this yellow shape.